Okay, we already refer to chapter 3 testing hypothesis. So we already deal with the hypothesis testing. Okay, I already give the definition where we have a hypothesis testing is just a process of using sample data and statistical procedure to decide whether to reject or not to reject a hypothesis. So in hypothesis testing, we will have null hypothesis and also alternative hypothesis. Okay, null hypothesis is your H0. So this one is actually a statement in which a population parameter has a specific value. Okay, for example, let's say we have population parameter mean. So in here we have your mu. So we just write down your null mu is equals to 30. Okay, for your alternative hypothesis, where we denote as H1 or sometimes other reference use HA. So this one is for hypothesis alternative. So that's mean this one, assertion of all situation which is not covered by the null hypothesis. Okay, that's mean is a statement different from your null hypothesis. Okay, so if we reject our null hypothesis, that's mean we will accept our alternative. Okay, so the rejection of the null hypothesis will imply the acceptance of the alternative hypothesis. Normally, we will reject the null hypothesis when we do not have sufficient statistical evidence to support our null hypothesis. Okay, then we go to the concept for test statistic. So that means test statistic is just a sample statistic that is computed from the data. So that means when we mention about sample statistic, we will have X bar, your sample mean, S your sample standard deviation, S square is your sample variance. Okay, the value of the test statistic is used in determining whether or not the null hypothesis should be rejected. So it's all depend on your value of your test statistic. And then we have a decision rule. Okay, a rule that specify the condition under which the null hypothesis may be rejected. Okay, and then we will have a stats table to compute your critical region and also your critical value. So you have a critical value, the value that you can get from your stats table, and then we have the critical region, the area in which the null hypothesis will be rejected. Okay, again, how you want to determine your value of your population parameter. So this one, based on 3 ways, either from past experience, your model or theory, or your external consideration. For example, if that one is already specified in your engineering specification or your design specification, so that means that is your population parameter in the null hypothesis. Okay, past experience ataupun past experiment, previous experiment, what is already considered ataupun what is already has been specified, that is your parameter in your null hypothesis. Okay, next, we already mentioned about type 1 and also type 2 error. Okay, type 1 error, you have to know the definition, which is rejecting the null hypothesis when your H0 is true. Okay, type 1 error is the same thing as you write your alpha. Alpha we call as probability of making type 1 error. So if you look at your tables, your alpha values will range from 0.001 up to the highest value is 1. Okay, but normally in your stats table we just have between 0 and something up to 0.5 lah. Okay, and then that one is your probability of making type 1 error. So if you mention about type 2 error, it's just failing to reject H0 or accept H0 when your H0 is false. Okay, for example, let's say this one is again related to confidence interval. If we have 95% confident interval, that means we are confident with 95% that our parameter mu lies between your lower limit and also upper limit. Okay, how about the other 5%? 5% is your error. So that means if your data set is not included in your confidence intervals, it might be an error is only considered as 5% error, but it depends on the researcher. If you want to use 95%, 99% or 97%, so it's up on the researcher. Okay, Okay, so this is just the procedure for hypothesis testing. So first, what we need to do is identify the parameter of interest. So normally you will write parameter for mean, you have parameter mu. Okay, you cannot write your x bar because we want to test is your parameter population. Okay, then you state what is your null, what is your alternative. We choose a significant level alpha. So normally alpha is given from the question. So determine the test statistic and then we state the rejection criteria and then kita decide lah and draw the conclusion. Okay. So in hypothesis testing, we have one-sided, two-sided ataupun one tail and two tail. Okay, one-sided, that's mean only one area. Okay, let's say let's say we have this one. So let's say you have null mu is equals to 3. Your alternative is mu greater than 3. So let's say you want to test at alpha 0.05. Okay, alpha 0.05, you find from your stats table, it should give you 1.6449. Okay, this is your critical value. Okay, how about your critical region? So critical region is depend on your alternative. When your alternative is greater than mu greater than 3, so that's mean we will reject H naught when Z test greater than Z alpha. Okay, reject H naught when Z test greater than Z alpha. Okay, so it should be over here lah. Okay, for example, 2.36. Okay, your test statistic is 2.36 is greater than 1.6449. So that's mean we will reject our null hypothesis. Okay, if you have again one-sided but your alternative is less than, so the decision rule should be reject H naught when Z test less than minus alpha. Okay, for example, this is your test statistic. And then again, let's say we have minus 2.36. Okay, minus 2.36. So minus Z alpha is over here. So this is your rejection region. So since our Z test is less than, so again, we will reject our null hypothesis. Okay, the last one, when you have your alternative is unequal. So when we have your alternative is unequal, it should be two-sided region. So two-sided region, so that's mean we will have minus Z alpha over 2 and also Z alpha over 2. So reject H naught when Z test greater than Z alpha over 2 or Z test less than minus Z alpha over 2. Okay, so alpha is 0.05, so you need to alpha divide by 2. So 0.025, find from your stats table, we will have 1.96. Okay, so check. The critical value is 1.96. So what is your test statistic? Okay, if this one is greater than, so again, you have to reject your null hypothesis and then we make a conclusion. Okay, again, the connection between hypothesis testing and also confidence interval. So how this one is related? So again, let's say, I already give you the example. Let's say confidence interval between 2.8 and 3.5. If our parameter H naught, mu is equal to 3, is lies within your confidence interval, so that means we will accept our null hypothesis. Okay, otherwise, we will reject our null hypothesis. Okay, or we can say this one, again, accept H naught, or normally we will write fail to reject our null hypothesis. Okay, itu dia punya relation ya. Connection between hypothesis testing and also confidence interval. Okay. Okay, so this one is just the idea how we want to formulate the hypothesis. Okay, so the same thing. Okay. So this one is your p-value eh. Okay, p-value is depend on your, either we have one-sided or two-sided test. Okay. So again, p-value is the smallest level of significance that would lead to rejection of the null hypothesis. So as I mentioned, if we have p-value is less than or equals to alpha, because alpha is already given. So if you have p-value is less than or equals to alpha, then we reject our null hypothesis. So otherwise, we will fail to reject our null hypothesis. Okay. Ataupun we accept lah our null hypothesis in other words. Okay. Okay, for free Z test, let's say if you want to find, okay, our Z test, let's say we already find about, if you refer to your notes, dalam module, okay, let's say you have your Z test is 2.15. Okay, let's say we have your Z test is equals to 2.15. Okay, so Z test is equals to 2.15. So you want to find your P value. Okay, but again, it depends on your two-sided ataupun one-sided test. Okay, one-sided pun you have to check lah whether this one is your upper or lower. Okay, so lower that means over here, upper is over here. Okay, for two-tailed test, that means we will have 2, 1 minus phi. Okay, you have P value. So equals to 2, 1 minus phi. Okay, 2.15. Okay, phi. So this one we call it as phi. Phi 2.15. The meaning is probabilities Z less or equals to Z test. Okay, Z less than or equals to Z test, which is Z less than or equals to 2.15. Okay, phi 2.15. If we refer this one is probability Z less than or equals to Z test. Okay, your Z test now is 2.15. So that means you need to find what is the probability Z less than or equals to 2.15. Okay, if we refer to our stats table, okay, you find, so this one, you have 2.15 over here. So you want this area. Okay, so refer to your stats table, 2.15. So 2.15 is given as, okay, 0.0158. Okay, this one is your, okay, probability Z greater or equals to Z test. Z greater or equals to 2.15 in your table is 0.0158. Okay, 2.15, okay. Okay, so that's mean we need to find this one. You need to find probability Z less than or equals to 2.15. Okay, so that's mean you have 1 minus 0.0158. Okay, so 1 minus 0.0158, you will get berapa? 1 minus 0.0158. Okay, 0.9842. Okay, you substitute in the formula for P value. Okay, so that's mean you have your P value. Okay, saya tulis sini Okay, P value. We have 2, 1 minus 0.9842. Okay. Okay, so you will get 0.0316. Okay, thank you. Okay, so that is the way we compute your P value. Okay, so again, but you have to remember or you have to check whether this one two-sided ataupun one-sided. Kalau two-sided, that means you just use the formula 2, 1 minus phi, 2, 1 minus phi Z test, where your phi Z test is probability Z less than or equals to Z. Okay, probability Z less than or equals to Z, you already know how to find that one. Okay, that means you just substitute in here and times by 2 lah. So if you have one-sided, if that one is your upper tail, okay, upper tail, so we just have 1 minus 1 minus physics test. So first find your physics test and then 1 minus. So you get your p-value for your upper tail. Ini ya, for your upper tail. For your lower tail that's mean for physics test. So ini saja, which is your physics test. So in this case, you just has probability z less than equals to z. So again, you will have 0.0158 lah dia punya p-value dia. Okay, so that is the way how we compute the p-value. So again, if you want to check whether that one, you need to reject your H0 or fail to reject your H0. So you check if your p-value, okay, for example, 0.0316, this one is less than or equals to alpha. For example, we use alpha 0.05. So we conclude that we reject our null hypothesis and then write down the conclusion. Okay, so that one is how we compute the p-value. Okay, macam mana kita dapatkan dia punya nilai p-value. Okay, but normally if we have already output from Excel, okay, the output from Excel is already give to you in terms of p-value. So based on your output, you just interpret. Maksudnya check lah p-value kamu tu kalau less than, that means kalau kita ada null hypothesis and also alternative, you can reject your null hypothesis and then you make a conclusion. Okay, so that one is on the p-value. So that is basically yang we already discussed on previous week. Okay.